the PET scan one, we're still waiting on the person who submitted that. So I guess just sort of kill time for the moment. How is studying going? I mean, are you starting to feel like see somewhat the light at the end of the tunnel, or is the hill getting less steep? Not yet. Okay. Are you fully aware there is actually no tunnel, and the light you see is a train coming the other way? Ah, perfect. Okay, now, yeah, you better put on a hard hat. Yeah, because the hard hat, that's going to be plenty to stop a train. Good. That should work out. Always planning ahead. Good call. Okay, I'm going to go ahead then and fire this up. So I made a designated letter inner. I don't think, I mean, I just have a feeling that it's not going to get a ton of people tonight. So that in mind, our MCAT, which ironically enough is now living in our house again. So, okay, so go ahead and get into these. So 2 questions and then one topic that I actually want to spend a pretty good amount of time on because it's had a pretty high frequency being on the test over the past 5 to 6 years. Okay, but this one, so starting with this concept, before I do anything, I want to go over what's going on in this cyclotron. So where it says gap, and they have this, what this should represent, I'm going to redraw this a little bit cleaner. But what does the sine wave represent in that circle? Oh my gosh, sorry, I'm just trying to write, it's not working. Voltage that's constant or voltage that changes, clockwise, counterclockwise, clockwise, counterclockwise. So AC or DC? Means it's AC, perfect. Now, the rationale behind it is the following. We start by putting some charged particle here. I'm going to assume it's a cation. And let's say the cation gets accelerated to this plate. It's going to move in a circle. And then when it comes here, it's going to get accelerated that way. Then it's going to get accelerated that way. So is it being accelerated across one way here, up, but when it gets over here, down? So is it alternating because it's got to be accelerated down, then up, then down, then up, then down, then up, then down, and up, etc.? So basically, it's an accelerator, but instead of accelerating in a long straight line, it's and so it's going to spin out. Every time it gets accelerated, so here it goes from rest to moving slowly. So it takes a small circle because moving slowly, speeds up a little bit more. So now it's medium slow, a little bit bigger circle, a little bit faster, a little bit bigger circle, faster, bigger circle, still faster, keeps on spinning until finally, when it exits the magnetic field, it shoots out. So does the basic design behind this device make sense? I'm going to get rid of my drawings here and just say that here's what we have is, again, particle being fired up, turned in a circle by a B field, fired down, turned in a circle, fired up. So every time it gets a little more acceleration, picks up more and more speed and spins out. Okay, so what if we increase the voltage? What if we made it double the voltage? Would that have any effect on how much it speeds up going across the gap? So what would the impact of that be? If the voltage goes up, if we use a stronger field, what's your gut feeling? Not math, but gut feeling. Voltage goes up. Should it have any effect on the charged particle? Okay, so 1 vote for yes. 2 votes for yes. So is that true? Does the force acting on a charged particle depend on the charge of the particle? No equations, just your intuition. Yes, exactly. F equals QE, perfect. Change in potential energy, Q delta V. Q shows up all the time. So the bigger the charge, the more it's going to accelerate, and voltage itself. The stronger the field, the more it's going to accelerate. So it should depend on both the voltage and the charge. Those are the 2 factors that are going to affect it. So there's 2 equations. The equation for the force across an electric field, parallel plate field, is force equals QE, but then there's also energy. The change in potential energy equals Q delta V. So I ask you in return, why did you ask me for equations? And it's a weird sort of question, but why would you care about equations? Yeah, I'll answer that one in a second. So good question. Exactly. You want a backup plan. You want a way to double check your intuition. If you're not 100% sure of one thing, you have an alternate plan. Perfect. Equations should be used as a tool to see how things relate to confirm what your intuition tells you. Exactly. So perfect answer. And V is for voltage. And I'm going to soon have a small v coming up, but can't you obviously tell that's a capital V? So sorry, because yeah, it's not clear. So what should I do to make it more clear? Probably if I do this, does that make it seem more capital-like? Does that make this look silly? Not exactly. So voltage is the change in potential to move. So you're thinking voltage, like the voltage of a field, will sometimes equal E over D. That is that the one you're thinking of? Yeah. So if you think about it, the voltage depends on how strong the field is and how long the field is. So long and strong. You want your field not so long and you want it strong, high voltage. If your field's not so strong but very long, it's low voltage. So your fields are your voltage, something long and strong. Oh my gosh. Oh, so sorry. Got that. I completely butchered that one. I sincerely apologize. It is the field is the voltage difference over the distance. Gosh, I said it right, but I totally said it wrong. Wrote it wrong. So the field strength is how strong over how long. So if you have a very strong field, high potential to move, high electric field strength, and vice versa. Strong electric field is going to give potential to move, but the longer the field, the more you weaken it. If you move the plates further apart, the field is not as strong. If you increase the amount of charge on each plate, the potential difference, potential to move, field gets stronger. So the field depends how strong and how long it is between the two plates. Sorry about that, but yeah, this is the equation. So I don't know if that looks somewhat familiar. Okay, on we go then. So if voltage goes up, what's going to happen to the speed? Speed is going to go up. So it's going to go faster across the gap. So if I go faster, I'm going to do a bigger circle. Faster still, bigger circle. Faster still, bigger circle. Oop, terrible that I did that. So if it speeds up, can it make it out in less laps? Can it get faster and do a bigger circle? Perfect. But it's limited by this point. You can only get so big in the circle. So it's kind of weird, but it ends up, it's going to come out with pretty much the same everything as before, just comes out sooner. So after telling you don't worry about equations, throw equations at you. So equations are going to pop up here. So I kind of have to erase because I planned poorly. I'll rewrite this here. V goes up, and then want to put electric field equal to voltage difference, the distance. Not so much resistance, but you could put a gel in there if you wanted to. So if you want to put gel on one side and something on the other, you could. I don't know of a device that does that, because basically you're trying to get the particle spinning as fast as possible. But you can definitely have resistance, whatever resistance might be. It might be electrical in nature, magnetic in nature, physical, like a gel. But yeah, they could mess with you, put a gel across. But for this one, the equation for kinetic energy, we got it on a previous question, but kinetic energy is 1/2 mv squared. There's my 2, but because velocity depends, it depends on velocity square, and velocity is going to be impacted by mass. M ends up on bottom, But notice there is absolutely no voltage in this. Depends on the charge, the B field, the radius, the M and the 2. But notice that there is no voltage. So therefore, kinetic energy is not going to be affected. And then the frequency, they gave you in the passage, the frequency equals QB over 2 pi M. Again, notice there is no V in that equation. So therefore, it's not there. And the magnetic field would remain unchanged. So actually, you know what? I need to put F and T on this one. I apologize. But for this one, no V in it, so it would be with more kinetic energy. This one, no V, so it remains unchanged. That's true. Magnetic field, changed or unchanged? Unchanged. B field is completely independent. So voltage describes the electric field. And then ion, we conclude that. Ion's going to come out sooner, the same. Yeah, the equation is being different here because it ends up that the kinetic energy, you can only build up some kinetic energy. So kind of weird type of question, but similar concept. If I drop an object down, or I let it slide down a frictionless ramp, in which case, the first one or second one will end up with more kinetic energy at the bottom. Classic type of trick question, because the answer is same. They both experience the same MGH. This one gets there sooner, this one takes longer, but the force in this one, mg times distance, h. This one, mg sine theta times distance h over sine theta, and ends up it's the exact same amount of work done, potential energy converted to kinetic energy, whatever way you want to look at it. They fall the same height, so they pick up the same energy. Same thing here, whether it's a weak field or a strong field, it's still going to pick up energy. By the time it's here, it is exactly 1/2 mv squared based on how fast it's going at that radius. So the radius is the same, and the radius depends on the velocity. So it must have the same velocity here. The mass didn't change, and the half didn't change. Okay, so what's the best answer on this one? After beating around the bush and labeling everything, best answer? Perfect. Okay, hopefully it seems reasonable. So moving on. For this one, if an electron is observed to travel through a certain region of space undeflected. So what can I conclude about something going through undeflected? What can be concluded? Okay, electron though can't really be electron with no charge per se, because electron I know has a charge. So there must be something else. No voltage, must be doing something. So there's definitely no electric field in that region, but perhaps a perpendicular magnetic field. Why is this one wrong? So why is that a false statement? If there was just a magnetic field, would it deflect it? It would get deflected. And then is B wrong for the same reason? Because if there's an electric field, it would get deflected. Okay, so if I have only two choices left, all I know, if it's undeflected, there's no net force, meaning force up equals force down. So if there's no field of any kind, you would be force up equals 0, force down equals 0. That would be one explanation. But could it be electric magnetic forces like this? So could it be the electric force is up and the magnetic force is down? This equals QVD. This equals QE. Could it be that these two are equal, like somebody just said? Would that explain it? Here's the BS part of this question then. because that is totally true. The electric force could equal the magnetic force, but did it say force and force or fields? So is that the word force or field that's right there? It is field. That is where it's different. Is the force in the same direction as the field, or is it perpendicular according to the right-hand rule? The field is perpendicular to the force. That's why your finger is perpendicular to your index finger, perpendicular to thumb, perpendicular to middle finger, or if you will, your thumb is perpendicular to your fingers when they point straight out, which are perpendicular to the direction your palm is pushing. So the fields would have to be perpendicular in order to generate forces that are opposite one another. Yeah, the reason A and B, I'm going to explain them both together. If you have one field but not the other, so if there's a magnetic field but no electric, or electric and no magnetic, either way, if there's just one field, then is there a QVB? Because an electron is moving. An electron has a Q and it's moving V. So if it moves through a B field, it'd be deflected. If it moves through an E field, just having a charge, it can be affected. E is going to accelerate it. So the point being is, if there's one field and not another, guaranteed to be. The only explanation for why it would go undeflected is either there is no field whatsoever, no E and no B, or there's an E and B and they are opposite of one another, equal magnitude or opposite direction. No, that's a catch. If it's parallel, so let's just say, let's draw this. So here's my electric field. If that's my electric field, then there is an electric force in the same direction. Actually, it's not true. Why do I need to be really anal? So if the electric field is pointing up, why am I saying that the electric force would be down? So explain to me why I had to change my rules on that one. Exactly. Electron's negative and fields point the way a positive would migrate. So if a positive would go up, negative would go down. If the B field was this way, so if my fields were parallel, as the question said, then my force would be perpendicular. Actually, let me draw that as a kind of like for three-dimensional accuracy. The right angle between those two. So does that make sense that this is going back into the page? I'm trying to draw it 3D accurate, but I don't know if I'm doing a good job. Because you would have field in one direction, motion in another, and then force in the third one. If you did your right-hand rule, actually electron would be left-hand rule, but the forces would be perpendicular. Does that seem okay? That's what's wrong with this one. Which makes this one false, leaving this as the only possible answer. Question mark beats 3 falses. So would you agree both this question and the previous one are kind of trick questions? And have any of you not yet done this homework set? It's a pain in the butt one. This one's a tough one. Okay. Second thing that was submitted, I'm going to go ahead and shift gears. Yeah, there's a lot to review on this one, but this is one of those that once you get it through it, and especially phase 1, it really does hone some things in. Okay. PET scan. PET scan is freaking genius, unbelievably complex, with the ability to ask unbelievably simple questions on it. So first and foremost, we need to figure out what exactly a positive electron is. I'm going to start by naming the things I know. The things I know are the proton is positive. I'm going to say it's heavy, meaning it has a mass. A neutron is 0. I'm also going to say it's heavy, relatively speaking. An electron is negative, and it is light, relatively speaking. So if you learn this is 9.11 times 10 to the minus 31 kilograms, how many learned that this is 1.6 and 1.67 or so times 10 to the minus 27 kilograms? Does that sound right for those? Not going to worry about the exact numbers, but it's around 1,800 times this. So it's about 1.66, 1.67 times 10 to the minus 27. So the point being, these two I'm going to call heavy, this one light. Okay. There is also in this world then less common things known as neutrino, which is 0 and light. And there is also positron, which is positive and light. And this is what I'm going to focus on. What charge is a positron? Positive, makes sense, goes with the name. And it is given the term symbol beta with a plus sign and a line over the top. The line over the top is kind of an interesting little thing that's going to be the meaning of this whole issue we get into. But the line over the top in this particular case represents something called antimatter. So what exactly is antimatter? An honest answer, how many have no clue? Sounds like something from a bad science fiction movie. Antimatter, no idea. So I don't know what antimatter is, so I'm going to have to resort to something I do know. Am I drawing a wave or an anti-wave right now? Okay, I guess, seems reasonable. What about this one? Looks like a wave, but if I try to put the two together, going down and going up, going down, going up, going up, going down, going up, down, down, add them together, what happens? Destructive interference. So can I safely say one is a wave, the other one relative to that is a did the anti-wave cancel the wave? Sure, okay. Let me go into something chemically related. If I have two electrons in a so-called bonding orbital, so two in the one pi to another pi, but I also have two electrons in the anti-bonding, what does that mean? Do I have a bond, anti-bond, or no bond? So if I have 4 electrons, 2 in each of these bonding orbitals, and 4 here. So if I have 4 bonding and 4 anti-bonding, what happens? No bond. No wave. So no 007, exactly. Bond, covalent bond. Okay, so for this one, is it simply an anti-wave cancels a wave, anti-bonding cancels bonding? So this is known as antimatter. Specifically, the positron is known as an anti-electron. So explain that to me using this concept here and here. So what is an anti-electron? What exactly does it mean? It's something that hates an electron, or something that when given a chance will cancel an electron? Cancels out an electron, exactly. Specifically, an electron. So how heavy is a positron? Which is part of the reason why I only gave one mass up here. Masses can't be negative, so it's not heavy. Specifically, it is exactly that weight. Positron, exactly. Somebody private chatted me. It's the exact same weight as an electron. They're same thing except complete opposites. Same mass, but opposite charge, opposite nature. One is matter, one is classified as antimatter. And you read, it's totally arbitrary if I call this a wave and this an anti-wave, just that they cancel. So we've chosen to call the electron matter, and this is antimatter. Okay, I'm going to erase the screen in 3, 2, 1, gone. I'm going to go in this notion. If I take a positron No worries. I mean, this seriously is sci-fi more than MCAT, yet it's definitely an MCAT topic, and it's a freaking genius medical machine. But here's what we're dealing with. If I have a positron and electron collide just the right way, the right orientation with the right initial kinetic energy, so to overcome the activation barrier, I can have those two annihilate. The matter cancels the antimatter, and you turn into two gamma rays, energy. So we have just discovered that matter can turn into energy. So is this an equation you've ever seen before? E equals mc squared, which I'm going to rewrite officially as, instead of E, I'm going to say the change in energy, the energy I gain in the form of two gamma rays, equals the loss of mass, c squared. Okay, off on a tangent for a moment. It'll make sense in a second. If I write this number, does this mean anything to anybody? What does this mean? Ah, perfect. You knew that all your life, or you learned that when you took OChem? Perfect. How many agree that was nonsense until you took OChem, then it was nice and easy? Or whatever it might be, wherever you learned it, you learned it. Okay? So I'm going to give you another number, and you tell me if this means anything to you. 511 kiloelectron volts. So QV, Q is the charge, kiloelectrons in volts, means nothing to anybody. But as soon as you study radiology in med school, this is going to be as obvious to a radiologist as this is to an OChemist. This number represents the energy of that photon and that photon. You get two photons of equal energy, which means if you see this number, can you work backwards and say, ah, annihilation occurred? If annihilation occurred, can you say, ah, positron was there? So help me out here. Is it possible, could I put a whole bunch of positrons somewhere and conclude they were all there because of this? Now I'm going to go on a real weird limb. What if I put positrons into your body and found that they all migrated to one spot? I saw a whole bunch of radiation coming out from one spot. Could that tell me something about what's going on in your body based on where all those positrons move to? Ah, ding, 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 ding. It's a marker. That's exactly what it is. We just need to figure out how to put this in here. So I'm going to erase what I have up here. And this amazing picture is going to teach us everything. So watch. Oh, wow. How many saw that? How many are like, wow, I could actually see the energy when those collided? It wasn't a big bang. This is the small bang theory. But here's what happens. If they hit with just the right amount of initial energy to overcome the activation barrier, you'll get a wave and an anti-wave. Because of conservation momentum, one is going one way, one is going the other. So if I could put a machine here to detect it, could I trace it back and figure out where the collision occurred? And in doing so, could I figure out, ah, that's where the positron must have been existing? Kind of. You trace it back, exactly. Sonar can be echoing or detecting, but sonar usually get just one wave. This is two. So if I have something coming out, so it's similar to that, but yeah, but still definitely trace the wave back, figure out where the source was. Okay, so here's my catch. I cannot make positrons. They're highly unstable. They hit an electron, they're done in a second. So instead, what I'm going to do is I'm going to come up with an isotope, in this case, fluorine 18. It's an unstable nucleus that quickly, by chemical terms, a couple hours, turns into a positron and gives me O. The thing I want to point out, if this is neutral and that's positive, is this O neutral or O negative? As a chemist, it kills me to not draw a negative there. You don't know how much my hand is shaking trying to draw a negative there. But in physics, we don't worry about charges. We just know that fluorine turns to a positron. It loses one positive from the nucleus. So instead of having 9 protons, it drops down to 8 protons and gives off the positive. And there is a negative. It's an O minus, but I don't care. So here's what I'm going to do. You need to teach me if this is a good idea. I'm going to take this molecule. What molecule am I starting to draw? But I can't remember how to finish it. Glucose, perfect. How do you know this is effing glucose? You flip the thing off, perfect. What I'm going to do is I'm going to replace this terminal hydroxyl with a radio-labeled fluorine 18. This is going to behave just like glucose. And the things I'm unsure, but you can teach me something. Can glucose travel through the body? Sure. Can it potentially cross the blood-brain barrier? Okay. Yeah, glucose can cross the blood-brain barrier. Okay. And it's not the only molecule you can use, but it actually is the most common one they use for a PET scan. So we load up this fluorine-labeled glucose. Yeah, in fact, it definitely picks it up at a high rate. So what if there was a tumorous cell in the brain? What would happen? Do tumor cells absorb glucose at a greater rate than other cells? Okay, so what cell is going to pick up the greatest amount of fluorinated glucose, radio-labeled glucose? The tumor cells. Cancerous or not sure, but tumor cells definitely will pick it up. And therefore, where are you going to have the greatest number of collisions of a positron with a random surrounding electron to give off this gamma radiation? From the tumor, exactly. So can you trace the glucose to the tumor and figure out where the tumor is by, would you call this hot spot or cold spot detection? Hot spot. That's a nickname for it if you're a radiologist. You don't have to know that term, but hopefully the concept makes sense. So here's how we're going to do it. We're going to label it. We're going to put that into the body, inject the glucose in the body. It's going to go through the entire body. So you're going to get radiation coming off everywhere, but you're going to get the highest concentration of radiation coming off from the tumor cells, which means the greatest amount of gamma decay coming from there. So we're going to put a machine around it. The machine is going to have detectors far apart from one another. I'm so sorry I'm trying to clear the glucose. Perfect. So the gamma rays are going to collect here and here. Do I lock it into this position, or do these detectors move around constantly? They move around. Positrons induce gamma radiation. Exactly. The annihilation reaction occurs. So I put a glucose in there with fluorine 18, which generates a positron, which meets an electron, which generates a gamma ray, which I detect. Lots of stuff going on, but I can triangulate by moving this around. Can I trace it back to the origin? Okay. Hopefully this makes sense. So does this seem like a reasonable technique? Because if it does, I want to scale it up. Good question. Where would you put this detector? Being pragmatic? Outside. It looks like this weird cage they put around the patient's head, and these things move. Well, I'm holding my hands doing it, but basically these are outside, let's say outside the ear, then might move to in front of the forehead, behind the head, slightly above, slightly below. Have any of you ever seen the device for a PET scan? That little spherical cage or almost globe-like thing they put in the head or chest or wherever they're doing it. I'm doing the head one just because that's one of the more common ones. But it might be worth actually literally looking up a picture, Google it, what it looks like. You're kidding. WMC has one on where? Oh, okay. So it was Psych Soch. Okay, perfect. Yeah. So it's not the actual machine, but the results from it. But yeah, so PET scans most often are used for brain imaging. That's the most typical example. But reality is they can be used for tumor analysis anywhere. Okay. Yeah, so PET scans, usually you do it with a tumorous, you can do imaging of abnormalities, not so much normalities, if that Makes sense. Or I guess technically you could do normality by just seeing brain activity. Whichever cells are most active in absorbing the most glucose are the ones that are going to radiate. What is the difference between tumor, like a tumor versus a cancerous tumor? So are there benign tumors and malignant tumors, cancerous and non-cancerous? Okay, what's the fundamental difference between those? Good luck getting any help from me on this one. But yeah, I'm choosing tumor cell because I don't know if it's cancerous yet. I know, see, it is true. Malignant, benign. I don't know if one is just the deadliness of it. And this is me being ignorant at this point and fishing for anybody who wants to chime in on bio expertise. Okay, so whether it's an active or inactive form. So you mean the difference is a benign tumor could have grown really fast, but then to stop growing, whereas malignant is continuing to growing? Yeah, yeah. Okay, interesting. No, this isn't holding up the class. This is one of those things that I'm curious about. And unfortunately, I can tell you all about the physics of the device, tell you all about chemistry of the device. I don't know squat about the bio, which is honestly kind of embarrassing because I freaking love how this stuff applies. But I never even stop and think that, yeah, you have two different words, so there must be some distinction. So no, those are always great questions, especially considering, yeah, maybe that'll never show up in your MCAT, but it's sure as hell going to show up in your medical experience. And for sure, you're going to end up seeing it in medical. Okay, that would make sense to me as well. I don't know why I think what you just posted is what I thought it'd be true, but I just don't know. Okay, so so I say this will at least detect a rapidly growing cell of some sort, whatever it is. So it'll detect glucose activity at a point, whether it's growth or not. Okay, I'm going to click. The same picture is going to pop up next slide, but I want you to help me with some questions. So if you're screenshotting, now is your moment. 3, 2, 1. So same picture, but now I want to analyze what's going on. So let's just say, for sake of argument, I'm going to put some radioisotope into the body. Do I literally have to make this patient radioactive by adding in F18? Okay, so how long do I want to be active? Tell me about, let's look at the extremes first. Let's look at 1 week and 26 seconds. Is 26 seconds practical or impractical? Why is it too fast? Perfect, gone before you get an image. By the time they get it into the body, through the bloodstream, into the cells where it's active, it has long since dissipated everything. Not practical. So way too fast. What's wrong with a week? Somebody said a week doesn't look good either. Way too slow because does that mean you get a high or low gamma emission rate? If it takes a full week for half of it to decay, that means you're getting a very intense or very weak signal. You're getting a very weak signal because it is barely decaying. It's taking all that decay and spreading out over an entire week, which means in a given second, maybe you're getting 1, 2, 3 rays. You're detecting the gamma radiation at the detectors. Yep. So because if it has a really long half-life, it's a really slow rate, you don't get a very high detection. So one of two things, you either have to give them much more radiation to begin with to get a high enough amount of gamma to detect, which makes them radioactive. And number two, Do you want a patient to be radioactive for a week? Because when they have this procedure, are they technically now, by definition, a biohazard? Sadly, they are. They have to sit in isolation for a period of time. You sure as hell don't want to have them in isolation for weeks. So being practical, what is a long enough time to analyze, but not so long that it becomes an issue? Yeah, ends up it is B. A is still just a little too fast. So here's my question to you, to how fast things get through the body. You've done the experiment on yourself and probably didn't even realize it, but how many at some point in their life have had asparagus pee? And how many know what the heck I'm talking about? So what is asparagus pee? Eat asparagus and you smell your pee. Everybody does it. Does it happen instantly? Does it happen in 8 minutes, 16 minutes, or does it take a while for the body to consume it and then process it, create the metabolite, and pee it out? So you mean to tell me if I had to pee, I'm going to hold my pee for a minute, I'm going to eat asparagus, and then I'm going to run to the bathroom and pee, would I smell it? One, it'd be crazy doing an experiment on myself, but I mean, are any of you enough of science geeks or bio geeks that you would actually try this experiment? How many are actually going to try that? See how long it takes next time before you smell the asparagus? Yeah, but for what it is, yeah, it'd be pretty harsh. It was instantaneous. It'd be terrible for the world. But yeah, it ends up, it takes about 20 minutes or so from my trial and error, 20 to 30 minutes before you first get the first faint hint of it. So the reality is 8 minutes wouldn't, it just, there's no way that's enough time. Even if you intravenous, put it in their bloodstream, get it into the brain, to get the image set up and ready to go, you've wasted 1, maybe 2 half-lives by the time it's up and monitored. So ideally 2 to 6 hours. So about 4 in the middle is a good time for it. Fluorine 18, about a 2 hour, little under 2 hour half-life. It's a pretty ideal number. Okay, sorry to belabor the point on this one, but hopefully this is kind of useful. And like I said, this may very well have been on in the last 7 years since they went to the new style MCAT, may very well have been on at least 3 MCATs that I am aware of, at least. It is very much in the pool. They like this concept because it catches people off guard. Nobody studies this, but is this kind of question you could answer intuitively? Oh, did you have this on yours? So there you go. And that is so cool. And was it one of those things you could deduce from the passage everything you needed if you had just the real fundamentals? Okay, and was it also intimidating at first? Yep, it fits their whole approach, their motif perfectly. Yep, and how it works, exactly. And so it's not complicated, it's just you've never seen it before, it sucks. So time to mess with you some more. Why are 2 photons generated? Concentration, charge, mass, energy, or momentum? Momentum. If one goes up, the other one goes down. Notice they're going in opposite directions. One detector here, one detector there. Concentration, momentum. Energy and mass are not conserved. Matter, M, is being converted into light. Yeah, but they're going in opposite directions. So they would, if they're going this way, they would annihilate or destructively interfere. But annihilation, they're going opposite. And then charge is conserved. There's no net charge and no net charge. That could happen if they're going in like 1 photon, 7 photons, 3 photons. Specifically 2 is because of momentum. Why is glucose with F18 chosen? It crosses the blood-brain barrier, very true, but this might not be a pick the right one question. Shit. Cells readily absorb it? True. F is similar in size to carbon? Huh? It's true, but I don't know if that's important. And how many agree? So this is true and important. This is true and important. This is true and important. This is true, but not so important. Is this where my TTF approach kind of fails? I should have said important, 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 huh? But that's still my best answer because that's still the one, it doesn't really matter that much. You're substituting for O anyway. Yeah, T and small t, kind of, but this is one of those that all four, I mean, can you argue that all four statements are true? So and this is that case, this is more cars than it is traditional science, and that I'm not trying for the true, I'm trying for the most relevant answer. And so in this case, yeah, I do want it to be able to go into the brain to study brain tumors. I do want cells to readily absorb it so it doesn't decay outside the cell and I don't detect it. And I definitely want it to be easily taken into the body and transported through the body, but I don't really care about the size of fluorine. I actually want it to be close to the size of O, not C. A few other random facts with this topic I want to bring up. Number one, could I use ATP instead of glucose? Would that be reasonable? Sure. Does phosphate, do I have an O in phosphate that could be replaced by an F? Like the last phosphate, the O minus dangling off, could that be replaced by an F? Sure. Glucose is the most common one you'll learn. That's definitely the one that's taught in most textbooks. But note that glucose is not the only thing that could carry an F18 in place of an O. ATP could also potentially be used. So, did I ask you a bio question, a physics question, or a GChem question? All of them. This topic can cover anything and everything I want it to cover. And like you said, it's even in the psych-soc in terms of brain imaging. But does this make sense how the PET scan works then? Okay. Why is it conservation momentum? Just got asked, and here's the reason why. Let's say I have my positron here, and let's say I have my electron here. The electron's going this way, this one's going this way. What is their net momentum at this point? They have the same mass because they're antiparticles. If they're going the same speed in opposite directions, zero momentum. It ends up that this sends out a wave. This one sends out an anti-wave. But they send it out in opposite directions. So what do you know? What predicts that two things will go in complete opposite direction? Conservation of charge, mass, energy, or momentum? Conservation of momentum, exactly. Where if something goes left, the other item must recoil right. If something goes up, the other one must recoil down. If this wave goes this way, this one goes the other. That's why we put a detector on each side, detecting the exact same wave, 511, in opposite ways. So now that you know this, is 511 the if you will, the radiologist common number as 1700 or 3300 broad is to an O chemist. And you realize that simple piece of information is freaking genius. So I'm going to mess with you a little bit more, and I swear I'll leave you alone. But how many look at this and think, this is pretty freaking incredible? I want to hit one more thing. I don't know if it pops up, and I apologize. I'll go back if I mess it up. Ah, I did. Ah, thank goodness. Oh, I know. If you think about the people who invent these things, and you know, I guarantee there's more than one person who thought they could, this is a good idea, this could be done. But there's one person who actually sat down and spent the time and tinkered and did it. And then proposed to somebody, yeah, I'm going to put toxic radiation into somebody's brain to study it. Give me some money to build a machine. So you have the crazy person who thought they could do it and the crazy person they talked into doing it, who now are geniuses because they came up with an amazing technique. It's pretty amazing. I mean, just science is so cool. Sorry to have that moment. But from these two numbers that are put here and here, I'm going to tell you the tumor is dead center, right in the middle. Do you believe me? Okay, fine. I think it's over here then. It's at point B. You are the cancel culture. Why? Keep on telling me no. What about C? Maybe. What about D? What is the best answer? Why are you voting on C? Where's the light brighter? Is the light brighter when it's close or far away? It's a hot spot. The closer it is, the brighter the light. So if the detector is getting this intensity, would you agree it must be a little bit closer to get more rays? So if I consider the ray that made it right here, barely detected, it would miss. The ray that barely made it there would miss on the other side. So do you agree this one's going to get a few more rays hitting it, but this one won't? So this will have a slightly higher intensity. So I could get where it is on that line, and then if I move detectors here and here, could I do that, and here and here? So could I triangulate it and eventually get to the center of that hotspot? This is so utterly cool. Yeah, I love this stuff, which now I need to tap into your insight, Jonathan. Knowing everything you just learned on this one, would any of it have helped on the passage as you remember it, if you remember it? You don't have to give us any details. So was it actually pretty fundamental information, but unfamiliar? Yep, and that's the thing. And yep, and I'm telling you, everything I just covered here is that same thing. I pushed up against a certain legal limit because I've never seen this passage. I never took this passage. But the things I've said have always made people like, yeah, that's exactly what I should have probably known. And possibly a few extra things. But I'm hopeful that you realize this is a great topic because it covers everything. It's unfamiliar, but it's something you can figure out or deduce as you're going. So to the person who proposed this, thank you so much. And I'm utterly curious, where and why did you ask about a PET scan? If you want to do it public or private, I don't care. But it's genius. I'm so glad you asked. Why? Where do you run into this? Phase 1 in GChem. Yep. Okay. It's meant to go with the nuclear passage down the road. And would you agree it's a butt kicker until you understand the basics of it, and then it's actually kind of cool. So big picture, this is exactly what I hoped you would get out of doing that passage. You start looking into this stuff. Yeah, nuclear, it's just, it fits in a different spot. It's just kind of weird. It's because it's a chemistry topic and physics topic. So I've always used it as a catch-all at the end of lecture. Oh, no. It's coming up as a separate lecture. But it's also coming up mixed in with some other things we haven't done, such as the Millikan oil drop experiment, which you've seen in another homework, but now I'm going to cover it. And it's kind of weird. That particular lecture is so important that I actually wanted everybody to do homework and all these other topics before they get to it. It's usually one of the last lectures given because you've already seen everything in homework. So now when you do it in class, it's like, bam, this makes sense, or bang, that makes sense. So it's about 3 or 4 different applications that we're going to see that are honestly just hot topics, things that show up on a fairly regular basis. Okay, I know I always say 5 to 6 plus or 4 to 5 plus or whatever, the plus being usually end up going the full hour extra. But with the student who submitted 9 questions pulling out and moving till tomorrow, that That's my next thing right there. So I don't want to go into any of her questions right now, simply because it wouldn't be fair or right. So we're actually done. I can't believe this. This is like, this covers everything. So, and it was a long lecture today, wasn't it? Yeah, so this hopefully balances it out. If you were January test, like mid-January, let's say, you should start taking your first, like the WMC sample test. Okay, perfect. First weekend or so in December. Okay, and something I saw it popped up in Discord, and so I just want to touch on this because we're all here. What I'm going to do for WMC, there's no way I'm going to mess up your full length test. That would be foolish. I'm going to do a few questions, a few freestanding questions, and passage 1, and I think it's 7 from the section bank for chem physics. So it's going to be altogether 18 questions going to do, and going to specifically go over this freestanding ones first to say, this is how they write questions. Yep, that's exactly it. Thank you for translating. Thank you so much. I appreciate that, because yeah, this won't mean much to anybody. Let me double check on 7, but I think that's the one. But I picked one that's a funky, weird looking physics passage that makes no sense to anybody, but we can figure it out. And I picked one that's biochem, pretty much hardcore biochem. And they're going to contain other types of questions. I don't care whether you look at these ahead of time or don't, it's irrelevant, because we're not analyzing what's right or wrong. We're not analyzing how do you get it. We're analyzing how do they write it. Can we reverse engineer that question and get insight into the way they're going to write the test? So the thing you have to realize, if you're hired as a test writer, does WMC show you everything they've ever written to model things after? Or do they give you things that are already there for public consumptions anyway and say, model this? Yep, they give basically the pack that you get when you buy from them. That's exactly what somebody who writes passages for them will get. Meaning, do they tend to repeat certain topics if it's a new writer? If it's a seasoned writer, they're going to start branching and being more creative. But new writers will mimic the style and oftentimes the topics. So if you ever sit there and wonder, why do they keep asking me about this stuff? I don't get it. It's because it's on one of these practice things that somebody writing practice materials or seeing practice materials to write for the real test sees and mimics. So terpenes are way more. Yeah. Oh yeah. The more predictable, the better. But it's only predictable if you reverse engineer it. But there are certain things, and again, how many, if you've done WMC materials before, notice terpenes can be disproportionately represented. How many have taken the MCAT and had terpenes and diene like interactions on your exam? Way more than college chemistry ever brought them up, ever. And it's simply because if it's in a practice test, it has a higher propensity of showing up on a real test because people lack creativity and confidence to think outside the box at first. Seasoned writers are going to throw anything and everything at you. But by and large, if it pops up in a practice test, it's going to show up. And then for sociology, psychology, if something has happened in real life of the past 2, 3, 4 years, somebody may very well write about it. So the WMC materials will prepare you very well for the psych. And if you end up getting 2/3 psych and 1/3 soc, you're in great shape. You only end up getting 1/3 psych and 2/3 soc. You have to wing it and figure those things out. But sociology, again, for people taking the MCAT, would you agree? It is kind of like cars, where you read about an experiment with maybe a table or a graph or a chart, but they explain a theory to you. They maybe give you one box, one data set, whatever they give you that information. And then you have to treat it almost like a cars passage. Like, how do the author conclude this? What do they feel about that? How many would agree that's a reasonable explanation of the soc passages, not psych, but soc? To prepare for those, there is not enough stuff out there. The amount of AAMC SOCH passages, minimal, hardly any. The amount of SOCH passages from other resources, trivial, hardly any. This is one you're going to have to learn the skill, and you can only get it by reverse engineering. Yeah, sociology papers, exactly. Yeah, that's everybody what Marissa wrote. Now the question is, Marissa, did you find you recognized most of the terms, or did it seem like they were making shit up to describe something you knew in real life but you didn't know? Yeah. Ah, cool. You did recognize? Yeah. For me, my opinion is if you tell me about the foot in the door principle, the door in the face principle, I'm thinking, okay, you're either trolling me and making shit up as you go, or you really believe that something we all know that, but you've given a name to it. And how often is it usually the second one? Yes. Everybody read what Jonathan said, Marissa agreed with, and I will verify. So many people said this. Yeah. And I mean, again, I don't want to give anything specifically away, but I seriously thought when I was taking the one version of the new MCAT that I've taken, I thought for sure two of them were sarcastic passages where people were making things up and the names just were ridiculous. Oh yeah. Yep. Gentrification, by all means, know what that term means. But yeah, and the reality is, um, everything can be traced back at some level to group A economically abusing group B in one way, no matter how it is. That is the basic law of how we've lived our life over however many years. Group A will take advantage of group B any chance they get. And the only thing is, who has the time and the wherewithal to write about these things? Remember, group A or group B? Group B is way too busy making a living. They know what's going on, but they don't have the time. It's usually a pandering member of group A. Something just to keep in mind. Just want to toss that thought out there. I mean, one of the things, sorry to get off on a personal tangent, but if somebody writes an IQ test, does that mean they define what all the answers are to that IQ test? So let's say you want to write an IQ test, you write 40 questions, and you decide these 40, if they get all 40 they're right, they're a genius. Did you just arbitrarily decide you're a genius because you decided what the right answer was to every question? It's a basic design flaw in everything. Every study is biased because every single study is done from a perspective. Rich people study the world because they have money and time. And it's just something to keep in mind, a general bias that you're going to find in all of life. And if you can find that bias within it. Oh, the MCAT is so biased. Yeah. I mean, and you know, the thing is, I will give the MCAT credit for being a little less biased than other tests. But at the end of the day, yeah, it's definitely, I mean, sorry, we could go on for hours where it came from and what's the purpose, but you have to do it. Yeah. And that's basically, if you have time to study it, that speaks volumes. And face it, if all of you are studying for the MCAT, you're probably relating to group A more than group B. And at different points, perhaps we've all been in group B, but at the end of the day, we don't have time to write about group B until we're in group A. So just something to keep in mind when considering these things. And I think it's important to always know who the author is, because the author decides what the right answer is. And so if you know who the author is, you can think that. Anyway. Anyway, that's just the little take on that. Oh, back to that third. The first exam should be around December 3rd to December 10th, like that weekend, that Friday, Saturday, Sunday. But I'm going to actually start in a week from Tuesday into the section bank. So probably that's as good a time as any. That first session when I'm doing it, start looking at QPACs first, section bank seconds, full length under real time conditions third. And yeah, for the QPACs and section banks, that's about right. And let me just actually real quickly say where everything comes from, because I think this will help in your planning and plotting. QPACs. They are from 1993 to around 2007, when they switched the MCAT from paper to computer in January 2007. These were questions that were part of something called the practice items. They called them, they had different names along the way. So QPACs first. And the thing is, they're still useful, but are they a little bit on the old side? So don't take any of them personally. But they are part of the pool of information that somebody who's writing for the MCAT will see. So they might do similar freestanding questions as these. Number two, the section banks. The section banks are going to include anything that has passages. These were basically 2011, around 2014. These appeared on the MCAT as an experimental section. Are the ones in the section banks the ones that were deemed good enough to make the real MCAT, or the ones that were filtered out because they had a small issue either in the passage or one of the questions? These are the ones that almost made it. They're almost good enough to be MCAT passages. So here's the problem with section banks and the beautiful thing of section banks. Section bank ones, again, are what test writers will model from. And usually they all come with 6 questions. Usually 5 of the 6 are really good, but one of the questions is messed up or something's wrong that it didn't quite make the cut. So they're great to look at, but every now and then there's going to be a question you just have to let it go. For anybody who studied for the MCAT before, how many would agree the explanations for these are awesome? You learn so much from their amazingly detailed 2-sentence explanation that they waste 1 sentence saying where they got it. Yeah, I mean, there's all sorts of profanities I can use, but they're the worst explanations you will ever read for anything. That said, yeah, it pretty much everybody knows this, so therefore it's true. I mean, moving on. You can find other explanations, exactly. I'm going to take the time to try to go through these and explain them. But yeah, there are plenty of good explanations floating around. And I think, I could be wrong, but some of the ones you may find on Reddit may very well been things wrote over the last couple of years that have sort of floated around. I sure hope so. I may have done some answer key dump somewhere. But yeah, if you can find it. Oh, no, full length I didn't mess with. I just did section banks. Yeah, and the thing is, I'm sure it wasn't the only one. There's lots of it. So find better explanations, but this is what I'm going to work on. And then the third thing, the full length, are from 2013, when they were written, to about 2017. And I'm going to put a question mark there because the last full length they released was a full length that was given then, but I don't know if it was also given later. So based on the realism, the sample test, you can toss it in with the section banks. They're about the same caliber. But full length 1 through 4, the ones that were given the actual MCATs, a little bit more realistic. So with each one, they get more realistic. But has the MCAT evolved, especially Psych-Soc, since 2017? So the full lengths will give you a false sense of security that there's more psych on it than there really is, and not as much soc as there really is. How many got sticker shock on the real test because you overstudied psych because this overemphasized psych? Yep. Got to make sure you throw some Soch in the middle of the psych you memorized. How many also used either the 86-page or 300-page document that, oh my gosh, Raj, that he made back in 2014? Yeah, MCAT Bros is aka Raj, aka I guess he's in every business you can be in, from schedule making to shoelace tying before the MCAT. But yeah, he did it. He made that list back in 2014 or so. Oh yeah, double aims. Yeah. Oh, is there an order for TBR and full length? I would do TBR, or sorry, now I do double AMC sample. And I would do TBR2, TBR4, TBR5, AMC 1, 2, 3, and 4. Those would be the 8 I would do. And I would, if you want better exposure, I would even consider replacing one of these with something you get from honestly anywhere. I do not believe, and you can read on Reddit who ranks what test where. You'll never find a consensus of any group that's great or any group that's bad. Everyone has their strengths and weaknesses. What's really interesting, a company basically has, I don't know, what word would use to describe the CARS book? Functional, piss poor, half pass or good, thick, whatever it might be. It's just the reality is, as poorly received as those are, our CARS passer is actually pretty friggin' spot on. The person we got to write for this was actually somebody right from the thick of things. So our very best CARS passages are buried in our exams. The book was somebody who just, I'll just leave it as the book, not as good. These are actually useful. If you don't do one and don't do three and you choose not to do one of these, go ahead and do the CARS and you'll get a good taste of it. Our psych Soch, too heavy on psych. I think that's a problem with every practice test you'll find. I think this one should be MCAT minus 6 days. About 6 days before your MCAT. And then what you should be doing is reviewing it 5 days before, and then the last 4 days before your MCAT. You should be spending those days literally going over all of the notes you wrote to yourself. After every lecture, after every homework, after every test, are you adding to an ongoing list of note to future self? Mention the first lecture, nobody does it, but eventually, when you start taking practice tests, start it then if you haven't started it now. So how many have started a list? Note to future self, things I want to look at right before the exam. Sorry, fell off. Yep, you're all in some state of it. It will get bigger. And it's going to get bigger when you do all these things. If you have not started it, I want you to start in earnest when we do the double AMC event in a week from Tuesday. That's when I want you to sit down and write an organized list of all the things you want later on. No, all little notes, like how many, perfect example from the circuit lecture, how many absolutely love that R parallel is R1 times R2 over R1 plus R2? How many found that to be really helpful? That should be on your list. That's one of the things you want to look at last minute. Yep, when you did phase one, when you went somewhere along the line, you may have seen it, whatever, and all of a sudden it really helped. Yeah, it's just basically a hot cheat sheet. If you could sneak in, that'd be great. But it's other things as well. It's little things like maybe that PET scan, something was interesting. Maybe you thought like, oh, fluorine 18, half-life of just under 2 hours, ideal is between 2 and 6 hours. Maybe you want to like some little note like that, but those last minute things that are in either high yield for one or two reasons. High chance of showing up the MCAT or high chance of helping you calm down and feel more prepared. Yeah, Post-its are the same thing. Oh yeah, and just the more you're reviewing, the better. And how many have already become neurotic to the point where you don't even give yourself a mental break in the shower? You're still even thinking about things in the shower. it was both awkward and absolutely genius. Oh, really? It is your getaway. There was a student years ago who was saying that they used to write equations in the steam on their mirror in their shower, and I thought, or not on the window in the shower. I thought, whatever works. No, the high yield one is the double AMC, and yes, there'll be high yield. Oh yeah, but yeah, okay, you're absolutely right. Yeah, the atomic theory lecture that'll have nuclear chem for part of it, and classic experiments. But exactly, that will have charged particle and electric field experiments, i.e., the Thomson, Millikan, and the mass spec one. It will have Rutherford. Will have a certain amount. The one that's going to happen for bio, I still need to figure out what's going to happen with Justin. He finishes his last med school block for this year on December 17th. He's coming home on the 18th. He'll do something at that point. Yeah, but so Fabiana, can the last week, will those Anki cards be useful? No, the Justin one is not included. And also, I heard back from Spencer, and this makes me very happy. He is apparently going to do a cell and a genetics mop up for you guys. Is this true that all of you know this, or is this something he sent to me that somebody was talking to him about? Okay, I'm so glad. Yeah, I reached out to Spencer before his lecture just to give him a heads up. Um, and I don't know if this trickled back to you guys, but this is the swan song for the class. Yeah, yep. And so sad. And it's just, I mean, it is what it is. I get it, but yeah, I mean, just long story short, are you still recording, by the way?